Students, today our topic is corrosion. As you may know already that corrosion is a natural but controllable process. Corrosion is a naturally occurring phenomenon, commonly defined as the deterioration of material, usually a metal, that results from a chemical or electrochemical reaction with its environment. Like other natural hazards, such as earthquakes or severe weather disturbances, corrosion can cause dangerous and expensive damages to everything, from vehicles to home appliances and water, wastewater systems, pipelines, bridges, public buildings, etc., etc. As you know already that there is no single figure for loss in any nation due to corrosion, but it can be estimated as 2 lakh crores per annum in India, and in US it is $300 billion per year. It is 3.2% of their domestic product. So the awareness to corrosion and the adoption of timely and appropriate control actually the measures the holds to abatement of corrosion failure. Unlike weather related disasters, there are time proven methods to prevent and control corrosion, and that can reduce or eliminate its impact on public safety and the environment as well. So there are definition is written on corrosion. Corrosion is as I have told you already, that it is deterioration or destruction of metals and alloys in the presence of an environment by chemical or electrochemical means. As per IUPAC, corrosion is an irreversible, obviously it is irreversible, and interfacial reaction of a material, mainly metals, with its environment, which results in its consumption or dissolution into the material of a component of the environment. The science of corrosion prevention and control is highly complex. It is very complex, and the professionals must understand the effects of environmental conditions such as soil resistivity, humidity, and exposure to salt water on various types of materials. The type of product can be processed, handled, or transported. The required lifetime of a structure or component, the proximity of corrosion causing phenomena such as stray current from rail systems, or appropriate mitigation methods, and other considerations before determining a specific corrosion problem and specifying an effective solution. So if we want to classify corrosion, it can be classified in mainly 3 ways. There are other classifications, but it can be classified in 3 ways, that is chemical and electrochemical, high temperature and low temperature, and wet corrosion and dry corrosion. These are main 3 components of corrosion. Now, the first step in effective corrosion control is to have a thorough knowledge of various forms of corrosion, the mechanisms involved, how to detect them, and how and why they can occur. In a simple way, corrosion is the natural deterioration that results when a surface surface of a metal reacts with its environment, and different surfaces, environments, and other factors add the complexity to that equation. So this is an example of a electrochemical nature of corrosion. It is examining a zinc solution, and the environmental effects, as I have told you already, the presence of oxygens and oxidizers which can form into oxides, or changes in flow rates, temperatures, concentrations of a reactant, pH value. These are the these are the main factors of corrosion. To prevent corrosion, there are many factors actually. As I have told you already, maybe I am being repetitive, but let me tell you again. There are environmental conditions such as soil resistivity, humidity, exposure to salt water on various types of materials, type or product to be processed, handled, or transported. Third one can be required lifetime of a structure. Fourth is proximity to corrosion causing phenomena such as stray current. And let us go through another part, that is each form of corrosion has a specific arrangement of cathodes and anodes in specific patterns or locations. And the most important types of corrosions are uniform corrosion, galvanic corrosion, pitting corrosion, de-alloying, atmospheric corrosion, erosion corrosion, which is very important, fretting, crevice corrosion, cavitation, stress corrosion, and corrosion fatigue. Here is a table which is an ASM, American Standard Method, that is classified corrosion types. You can see which are the general corrosions, which are the localized corrosions. The general corrosions are atmospheric corrosion, galvanic corrosion, general biological corrosion, and high temperature corrosion. Those are categorized under general corrosion method. And there are localized corrosions such as crevice corrosion, pitting corrosion. Those are very important. And localized biological corrosion. These are metallurgically influenced corrosion such as intergranular corrosion. Stainless steel, you can see that in the chapter, stainless steel suffers this kind of corrosion. De-alloying corrosion, another kind of metallurgically influenced corrosion. There is mechanically assisted degradation like erosion corrosion, fretting corrosion, cavitation corrosion, and corrosion fatigue. And some are environmentally induced cracking such as stress corrosion cracking, hydrogen inclusion or hydrogen damage, solid metal induced embrittlement. Now, what is localized corrosion? Localized corrosion is unlike general attack corrosion. Localized corrosion occurs at discrete sites or metal surfaces. Those actually I have included here, that is pitting corrosion, crevice corrosion, these are. And the general corrosion or uniform corrosion is that leads to relatively uniform thinning on sheet or plate materials. Mainly it is caused by misapplying materials in corrosive environments. General corrosion can also be tolerated because the effect of metal loss is relatively easy, or to assess the allowances are relatively easy. So this is already the classification of corrosion. Now let us go through about the crevice corrosion or localized corrosion. As I have told you already that the localized attacks are more fatal or more deadly. The corrosion is generally confined into one localized area of one metal. This type of corrosion can be initiated by concentration gradients due to iron and oxygens, and accumulation of chlorides in the crevice will aggravate the damage. Materials like alloy composition and metallographic structures, metal to metal, non-metal type, and these are some kind of corrosion which is written down here. Now let me go through about pitting corrosion. Pitting corrosion is a localized form of corrosion by which cavities or holes are produced in the material. Now pitting is considered to be the more dangerous than uniform corrosion because it is more difficult to detect or predict or design against. The corrosion products often cover the pits. The small narrow pit of a minimal overall metal loss can lead to a failure of entire engineering system. Pitting corrosion, which for example is almost common denominator of all types of localized corrosion attack, may assume different shapes. It can be of different shapes. Pitting corrosion can also produce pits with their mouth open or uncovered. Pitting corrosion is a form of corrosion by which cavities or holes are produced in that material, as I have already told you. Pitting is generally initiated by localized chemical or mechanical damage to the protective oxide film. Localized damage or poor application of protective coating, the presence of non-uniformity in the metal structure of the component, that is non-metallic inclusions. They also theoretically a local cell that leads to initiation of a pit can be caused by an abnormal anodic site surrounded by normal surface which acts as a cathode. The surface is acting as a cathode, or by presence of an abnormal cathodic site surrounded by a normal subject. A pit, whichever is disappeared. Now let us discuss about the galvanic corrosion. It is often referred to as dissimilar metal corrosion. Galvanic corrosion is referred to as dissimilar metal corrosion or electrolysis, you can even call it. It refers to corrosion damage induced when two dissimilar metals are coupled in a corrosive electrolyte. Two dissimilar metals are coupled in a corrosive electrolyte. It occurs when two or more dissimilar metals are brought into electrochemical contact under water or anything else, or salt water. When a galvanic couple forms, one of the metals in the couple becomes the anode, and the other one becomes acts as a cathode. And the cathode corrodes slower than that of the anode. In case of galvanic corrosion, either or both metal in the couple may or may not corrode by itself. When the contact with a dissimilar metal is made, however, the self corrosion methods, self corrosion rates may change. Corrosion of the anode will accelerate corrosion of the anode, and corrosion of the anode will actually accelerate the corrosion rate. And the driving force of corrosion is a potential difference between the different materials in case of galvanic corrosion. So students, today I am closing the chapter with it, that is with galvanic corrosion itself. Next day I will cover the rest subjects or rest topics including corrosion. Please study at home and stay safe. And if there is any other questions in your mind, you can contact me through WhatsApp or phone or anything else. I'm always available. Thank you very much.